Okay, welcome to this video for A-level trigonometry, and this is about the addition formulae. Okay, and it's about finding a result for the sine of the angle alpha plus beta in terms of just sine and cos of alpha or beta alone. Now let me show you how this works. So in this triangle here, we have our hypotenuse here alongside of 1 unit, so that's the number 1 there, okay? And the other vertices are variably labelled P, Q, R, S, T, U, and so on. Okay, and what we're going to do is we're going to find some of the angles, the sines and cosines of the angles in terms of the lengths of sides in this triangle and this triangle here. Okay, so let's start by saying that the sine of the angle beta, okay, so we'll start by saying sine of beta, okay, which is the opposite over the hypotenuse, is the length TS over 1 using this triangle here. So sine of beta equals TS over 1, which of course is just the length TS. Okay, so that's the first fact we can deduce from that diagram. So we'll just make a note of that. And we can also say that the cosine of beta, okay, the cosine of the angle beta is equal to the adjacent over the hypotenuse, which is PS over 1, okay, which is therefore just PS. So that's the second result that we're going to be using in our proofs. Now, I can also write an expression for sine alpha. Now, sine of the angle alpha from the diagram we have there, okay, is equal to the line RS divided by the line PS. Okay, so I can say that the length RS over PS is the sine of alpha. Okay, and I already know that PS is the same as the cos of beta. Okay, so if I just highlight that and that, okay, I can now say that because those two are the same thing, that sine alpha is also equal to RS over cos beta. Okay, and from that I can conclude that the length RS is actually equal to the product of sine alpha and cos beta. Okay, so RS is equal to sine alpha, okay, times the cos of beta. Okay, now if I take the whole angle here, sine alpha plus beta, so now I'm going to look at the sine of the angle alpha plus beta, okay, which is the larger angle here, the sum of those two, I can see that that's going to give me, okay, TQ over 1. So there's the opposite, you see, TQ, the whole of that line over the hypotenuse, which is 1. So that equals TQ over 1. And TQ over 1 is just TQ. Okay. But I also note that TQ can be split up into TU plus QU, or QU plus UT. Okay, QU plus UT. Okay, and that's all over 1, so I don't need to worry about that. So QU plus UT. Now, QU is the same as RS from this diagram, okay, because they're parallel sides of a rectangle. So I can now say that that's equal to RS plus UT. Okay. Now, we know that RS is the same as sine alpha cos beta. Okay, so RS we've already identified as sine alpha cos beta. So just make a note of that for the moment. And UT, well, we're going to look at UT in a bit more detail now, because what we can see is that if this angle here is alpha, this one up here is also alpha because it's an alternate angle. And by a process of recognizing two similar triangles in here, we know that this angle here is also alpha. Okay, so what we're going to do now is write an expression for cos alpha in terms of adjacent over hypotenuse. Okay, so I can say from this triangle here that the cos of alpha, okay, the cos of alpha is equal to UT over the hypotenuse of that triangle, which is TS. Okay, now you might notice that we've already defined TS as the sine of beta. Okay, so that is equal to UT over the sine of beta, which we discovered earlier. Okay, so we now have this situation that if we multiply both sides of that by sine beta, we get that the length UT, okay, is the same as cos alpha sine beta. Okay, so I'm now going to pull together two very important results, and that is this one here, okay, that UT is cos alpha sine beta and RS is sine alpha cos beta. Okay, so if I take those 4 items there in the yellow rings, then I can say that the sine of alpha plus beta, okay, so the result we've got here is that the sine of the angle that's made of alpha and beta added together is equal to, well, it's equal to QU plus UT, which is the same as RS plus UT, which is the same as sine alpha cos beta, okay, sine alpha times the cos of beta plus the cos of alpha times the sine of beta. Okay, and that is one of the addition formulae. So for example, if you put some numbers in here, so if I thought of the sine of 75 degrees as being the sine of 30 plus 45, it would actually be the same as doing sine 30 times cos 45 plus cos 30 times the sine of 45. Okay, and if you check that out, you'll find it's true. So this is another identity that we can use Okay, and it's one of the addition formulae. And it opens the way to a whole load of other possibilities. For example, if this was alpha and alpha here, in other words, this angle was split in half, it gives way to the double angle formula. So the sine of 2 alpha would be sine alpha cos alpha plus cos alpha sine alpha. In other words, it would be 2 sine alpha cos alpha. Now, this is the result for sine alpha plus beta. You can use the same diagram to prove sine alpha minus beta, cos alpha plus beta, and cos alpha minus beta. And from that, you can derive an expression for tan alpha plus beta. And you can also derive what's called the factor formulae. And I'll just briefly show you those on the next page, and then we will look at those in more detail in another video. So let's just look at the next page and see what those formulae are. They're all provided on the formula sheet in the A level. We've done the first one, sine of A plus B equals sine A cos B plus cos A sine B. And as I said, you could replace the plus with a minus there and the plus with a minus there. That's another result. And there's a slightly different result for cos A plus B and cos A minus B here. And in another video, I'll show you how to derive the tan function and the factor formulae which are here. Okay, so I hope that was a helpful introduction to the addition formulae.